Hello, hello, YouTube. We are gonna talk about religion and intelligence today, and the nature of this relationship, since it has been disputed by some people. And it happens that the person disputing this is Dutton et al. Again, we have a Dutton conflict, and Dutton is joined by Jan Neuenhaus, some of his former students, Dimitri van der Linden, and Guy Madison, our Swedish prof. And against Dutton et al., we have Dutton et al., where al is me. And so we have these two opposite papers that are in the same journal on the same topic, 1 year apart. And the first one you gotta talk about that one. That is the Jensen's method or method of correlated vectors meta-analysis on the religion intelligence relationship. For many people know that religion and intelligence, if you do kind of correlations or whatever, that this relationship is negative, at least insofar as all samples in modern times are concerned. Maybe not wasn't the case in the Middle Ages, but whatever the case there. But as we'll go into with the details, Dutton et al., they find that this is not G-loaded, and so the correlations are not stronger to the tests that are more related to intelligence, which they should be if it's an actual relationship to intelligence. And so in our reply here, that's the one this video is based on. That one we basically say why this method didn't produce the right results in this case. And of course we have Dutton against Dutton, so I could not avoid including the very best meme. And so let's talk about the method of correlated vectors, or the Jensen method. So the way you think about it here is that you have a certain data set where you've measured intelligence with more than one test. In this case, I've drawn 9 tests, but the number could be anything you want. This method, of course, better the more tests you have. And each test is, the performance on each test is related to intelligence. So you can see the G factor of intelligence causes variation, and the other tests also have some non-G factors that also cause these. So this, for instance, ability A could be verbal ability, and these are the free verbal tests. And this one is maybe spatial ability, so this is free spatial test, and maybe this is like memory. And what you're interested in with the Jensen method is the relationship of these kind of loadings to the relationship of the relationship of each test to religion and these loadings to intelligence. And so in this case, we can see that I've drawn in some lines. In this case, intelligence has a positive effect on religion, and ability C is a negative. So it may be the case that that even though you're doing IQ as an overall score, it measures more than just intelligence. It also measures other abilities that are tapped by this test. And so if you have kind of an unbalanced test, let's say you have given people 5 tests, but 4 of them are spatial tests, well, then your IQ score from this is tainted or colored by the memory component or the spatial component, which is larger than normal. And so we have to see, and so the Jensen method, that's the simplest possible method. You can use this whenever you can just kind of find these test level association with some outcome, whether it's religion or race gaps or incomes or something, that doesn't really matter. Then you simply take the correlation of each of these, and then you relate those to the correlation of this outcome you're interested in this case, religiousness. And so, of course, if intelligence is really causing, say, high or low religiousness, then the tests that are more related to intelligence, they should have a stronger correlation also with religiousness. And so you will get either a positive or negative correlation from the G loadings with the associations with intelligence for each test, depending on which direction, positive or negative, but not zero. And the same thing for ability A, if it's this ability, let's say memory. A better method, generally speaking, is confirmatory factor analysis, where you can just directly fit these and see if this model fits well. And a different method is a differential Eisen functioning, which we'll also cover here. And so here's the key table from the first Dutton paper. And what we see here is that they have these samples. They're essentially 2 studies, and you can see they're comparing these different religious groups probably in the Netherlands, since it's the Dutch Reformed, or it might be Belgium. You can see they have a test, the general intelligence test, or whatever the GIT is. and Gröninger intelligence test, I see. And it has 10 subtests, and you can see these are the correlations they're getting. They're kind of all over the place, and the sample sizes are not too small, but also not kind of large. The only one that's really large is this one, and that one produced a slightly negative result on a battery with the 9 tests. Another like weird, I guess, a German test. And the problem here is that these associations, if intelligence really causes a lower intelligence, you'd expect these correlations to be generally negative, which they are. There are 7 correlations, and 5 of them are negative. So it's directionally pointing in that direction, though not with statistical certainty. The problem with this analysis is that we look at the mean scores of these groups. They're down here, and so, for instance, we see the Roman Catholics are essentially at 98 IQ, and the Dutch Reformed Church are at 100. So there's only a 2 IQ gap between these, which is very small, and that's very similar with the other ones. So here's the problem. Every time you use some kind of value, say the correlation of intelligence to religiousness, or a given measure of intelligence, say a memory test or a spatial ability test and so on, there's going to be some error. And the smaller this correlation is, the more error you will have relative to the signal. So unless your sample sizes are extremely large, then you cannot really study with Jensen methods these small gaps. And as we saw, all the gaps are small here. So what you intuitively can deduce, you don't even have to do the statistics, although we did them, of course, is that the power or the precision of this analysis is tiny, and trying to do it will not really accomplish much of anything because you don't have enough sample size to give you enough statistics to show this. And to show this was the case, I simulated data, and so these are the on the different boxes you have the different actual true gaps, say between 2 groups. It can be religious people and atheists, or blacks and whites, or men and women. The groups don't matter. Rich people, poor people, whatever. And what you see is the average correlation that you get when trying to use Jensen's method. And this plot is assuming, I think, 10 tests with the same pattern as this one. And so what we really see is that when the gap size is something like 1 or 2 IQ, we're in these boxes, what you really see is that the average correlation you're getting when your sample sizes are like in hundreds here, the average correlation you're getting is only very slightly above 0. I mean, the true correlation here in terms of theory is actually 1.0. They're all 1.0 if you just have enough power. So the only thing that's making these values closer to 0 is that the imprecision in this case with this method results in the estimates being pushed towards 0. So it's biased towards 0. And so all these values are really 1 if you had enough sample size. And that's what you see as we go from left to right. The sample size is increasing. And over here we have 10,000 people. I cannot remember if it's 5,000 in each group or 10,000 both. But you get the point. Is that as you go over here to the right in each plot, the sample size goes up, or the sample size goes up, and therefore also the statistical precision. And so what we see in these cases with the very small gaps, you remember a D.1, you have to multiply that by 15 to get IQ. So this corresponds to an IQ gap of 1.5 IQ, and this one to 3. So that these are the gap sizes that were used in this paper, maybe this one. But what you see is that despite having sample sizes that are in the hundreds, this is a logarithmic. So like here would be like 300. You see, you're not really getting a lot of signal relative to the noise. You're mostly getting noise. And so each dot here, that corresponds to one simulation. So when you only have a few samples, maybe you got lucky, maybe you got this one down here, you got this one up here. You can see averaging across a bunch of samples like this will not produce the true value of 1, that there's a negative bias. It's only really when the gap sizes becomes quite large. For instance, if the sample sizes are both, say, 1,000, and the real gap size is 15 IQ or 1 standard deviation, then the correlation will be very close to 1. Essentially in every study. But that's not the case in this study, and that's why this study is uninformative, because of this negative bias. And so we get this problem that often happens in science, is that you want to reach some conclusion and you have a nice study, but it just turns out that your study is basically underpowered or imprecise to conclude whatever you want to conclude. So essentially it's maybe not exactly useless. You could throw it into a meta-analysis in the future, In the case, however, of Jensen's method, they're actually useless. You cannot metalize your way out of this one. You cannot apply like fancy corrections to really get this one. It would be very difficult. You can see with this, you don't have a chance when you observe one of these to guess whether the real value lies up here or down there or somewhere in between. It's just too imprecise. This method does not work when the gaps are small. You have to do something else. I mean, okay, it does work if you have 10,000 sample size or even more. As you can see, it will moving in the right direction here. And of course, we don't want to be lazy, so we checked this idea in a different dataset that has even more people. And so here we use the Vietnam experience study, which is an open dataset now that it has been liberated. People have been using it for a while. It's a dataset that follows 4,500 or so men who were drafted or enlisted in the US Army in the 70s or late 60s. These were the Vietnam people. And roughly 2/3 of the sample went to Vietnam, and the other third, they went somewhere else on duty. They may went to Korea or Japan or East Germany or like West Berlin or whatever at the time, and it's been used by, well, hundreds of studies. Interesting thing here is it has a lot of interesting variables, measured intelligence twice with 18 years apart, 19 tests, which is huge, medical history, psychiatric stuff, hundreds of other variables, and you can actually go to this website and just you can look at the variables if you're interested in those, or you can just literally download the data and do whatever you want with it. It's totally public. And of course, we set up this website. So religiousness as a continuous variable. So the one thing we saw with these with the Dutton studies that they used the group level comparisons, and as we saw, the gap sizes were extremely small, and so we're up here because the d-values are extremely small. And a better way to study these things to get more power is to use a continuous variable instead of a binary one, like these group differences. And of course, religiousness is not really you believe in Jesus or not. It's also more of a matter of how much do you really believe in Jesus. Some religious people are quite doubtful, or some atheists are doubtful, and some people are very certain. They're like, God definitely exists, or God definitely doesn't exist. What we see is that I found all these items, or Josh and we found these items in this pool, and these are all from the MMPI, the Minnesota Multiphasic Personality Inventory or something. And this is a very cool test. It has like 600 items with all kinds of weird content, and we found these 10 items or so, or is it 12? That 12 that are related to religiousness in some sense. And what we see is that half of them are actually very pure, like they're measures of like belief only. Like I believe there's a devil and a hell for an afterlife. It's like purely a matter of belief. And some of the other things have to do with comparisons with other people. For instance, I'm very religious more than most people. You're doing a kind of comparison intuitively to see, and a minister can kind of do some of this stuff. I guess this one should have been in the other group. Anyway, I go to church every week. That's more of a personality measure than a belief measure. Here's the religiousness scores. If you put these 12, or the entire collection, or 6 items into an item response model, you get this distribution of scores, which we can see is fairly normal. Those over here are going to be the atheist cluster. So essentially there's kind of a normal variation, and then there's a bunch of like committed atheists over here. And of course the ones with pure based on only 6 items, it's less normal because you don't necessarily get a normal distribution just from so few items. But you see the red one is pretty normal, except for this left bump over here. And if we relate these to intelligence, you get these plots where we see that the correlations are kind of sizable, minus 0.18 to minus 23. This is the pure one, and the pure one is slightly stronger than the other one, which by 0.5, so it's well, not slightly, it's quite stronger, and 20%, 25% or so. Nevertheless, what we see is that the blue line is the nonlinear fit, because we might be concerned about a nonlinear fit, and the orange line is the linear fit, and the same over here. So what we see is there is definitely a pattern. Here we have applied Jensen's method, and because we have a continuous variable and a larger sample size, we have much better power. We're in terms of this analysis, we would be down here somewhere. And so what we see is that we have these two variants, because one of them is related to the factor of religiousness, where we included all 12 items, and the other one is the one we only included the 6 items. So this one is the bottom one. And so what we really see is that the G loading here, that's the loading of each test relationship to intelligence. So we see some of these GPT whatever tests. These are hand dexterity tests, and it's basically put it like wooden stuff into a kind of test to see, kind of like the idiocracy scene, where you put these things into it, and like a square goes into a square hole, and a triangle into a triangle one, and so on. And the CVLT is like a memory test, and there's some more kind of memory or other tests up here. Down here we have the tests that are very highly related. For instance, the AFQT is not a single test at all. It's actually an average of 4 other tests. We just don't have the other 4 other tests independently, otherwise we should have used those. So this is kind of an average. But what you see is that these G loadings are very high, and what we also see here is that the stronger the G loading as we go from left to right, the more negative the relationship of each test to religiousness. And so this is exactly what you expect once, if you think that intelligence itself, not just say spatial ability, is negatively related and or even causal for religiousness, and you get the same conclusion whether you only use the 6 items or the 12 items. And we can go further, however, because we also have the items from some of the tests, and as a matter of fact, there are 193 items that are useful out of 210 or so, and the last few items are not included. You may ask why. The reason for that is that the last few items are passed by very few people. Either very few people get them right, or almost everybody gets them right. And so the estimates for these are very noisy, because few people are really contributing much to this. But what we see here is that the same pattern we get with the test level, we get with the items, where you see that there's a negative relationship, so that items that have stronger G loadings, they do have also stronger negative relations with intelligence. The pattern is less strong than here. Here where the correlation goes, if you were hypothetically to have a test with a G loading of 0.1, this would go over here somewhere, and you would end up with like 120 or so. And over here maybe 120, 125. What we get with the items here is maybe somewhat less. Here we're 0.6, we're at minus 0.1, so maybe we'd get to minus 15, and a bit lower also here. And we see there's a lot of difference between which kind of test you're taking, and especially these information tests are down here. And also this is the other analysis using the 6 items instead of the 12 item religiousness measure. And we see one conspicuous outlier up here. It's an item that has a half decent G loading of 0.4 or so, but has a positive relationship with religiousness. And this item is from the Wechsler revised version information test, so it's a knowledge test. And I managed to get a scan of this item, and it's item 18 here. And so what you really see is that what is the main theme of the book of Genesis? It has to do, of course, with the creation of the world and so on. And religious people know this more than atheists, because they're not really interested in this topic so much. And that's why you get these weird outliers. So really, you see that this item is actually biased for this thing, and the Jensen's method plot here will actually find you the biased item, as we also saw with the prior paper on sex bias in tests. We can also do regression analysis, because there are some confounds we might want to adjust for. Here we're looking at the people, so not the items. And so in the first 3 models, we're looking at, I guess the first 4 models, we're looking at just standard stuff. The correlation here with G is minus 21. I think 21 is slightly higher. I think this has to do because of the standardization with white people, because this value is the slope, and it's standardized to whites instead of the full sample, which is this value getting here. That's why it's slightly different. Nevertheless, what you get is that if you then add controls, let's say we control for race, what we see is that this relationship does not really change. And in this sample, Asians are less religious than you'd expect based on their intelligence, but the p-value is just below 0.1%. But there's very few Asians in this data set, like 20 people, so we shouldn't really make much of this finding. Maybe it has something to do with immigrants. Maybe they don't believe in this Christian stuff so much. Anyway, we see controlling for these other races that didn't really do anything. If we add interactions, so what we're really saying is that maybe intelligence works differently related to intelligence by race. What we get is that the black one here is positive, and so the relationships will be more negative because you have to multiply this one by that one. So among blacks, the relationship appears to be stronger, but again, the p-value is just slightly below 1% here. So we're not really impressed. Again, Asians and blacks appear to be somewhat more religious, even controlling for intelligence. And if we add social status stuff, income and education down here, we still find that the relationship to intelligence is not explained by either income or education. In fact, these variables are actually not significant. I mean, the p-value for education is just below the 5% cutoff, but we are using a 1% cutoff here because we don't want flukes. And if you do the same kind of exercise, but you limit it to white people, you don't really get anything different either. The sample size goes down, but now it cannot be due to any other kind of red race confound that we have not control for. So it seems that no matter kind of what we do, intelligence is like robustly negatively related to intelligence. And the interesting thing is that if we take the Jensen method and we reverse it, so instead of looking at G loadings for intelligence tests, we look at religiousness loadings for each of the 12 items, we get this pattern in that we have 12 items and the loading on the religiousness factor goes towards 1, and this is the IQ gap of people who said yes or no on a given item. And we see something odd, right? The people who go to church every week are actually slightly smarter, despite atheists being smart on average. So it would seem that there may be a bunch of atheists that are going to church for social reasons. Then there's a bunch of other traits up here. No patience for true believers, very religious, believe in second life. Some of these are related to behavior also, and they don't really relate much negatively to intelligence, -2 IQ. But then we have some other stuff like belief in God and thinking yourself as a special agent, which kind of, I guess, is somewhat schizophrenic, and the prophets are accurate, and so on. These items have much stronger negative relationships. But we see overall this correlation is totally nothing. And what this really tells us is that there's a lot of heterogeneity in the relationship of each of these items to intelligence. We went into a lot more details with this in the paper. We also controlled for some other confounders, like maybe this belief in the devil and hell is only so strongly related because it relates to intelligence more than the others. But we found this is not the case, adjusting for all the same thing as we were adjusting here. They didn't really change anything. So to summarize, we have a refutation of Dutton's The Myth of the Stupid Believer, that he was previously saying that basing some ideas on this, like maybe it's mostly an autism thing with religiousness. It's not totally wrong, right? Religiousness does relate also negatively to autism and more to schizophrenia, because schizophrenic people are essentially over-attributing variation in reality to like intent, to agents, like conscious agents. And of course, the largest over-attribution you can do is like believing in some magical creator like God, or some other thing that we used to have, or kind of an Illuminati, or some of these kind of standard conspiracy stuff. Whereas the autist people are under-attributing stuff in general to human intentions, and they're much more into like systemic thinking. So that's what's the main other theory of Dutton, which I think is also true. It just happens to be that both of these models are true. Intelligence is negatively, probably causally negative for religiousness, and also say autism is independently of this also. Here, one hopefully thing we hope of this study is that people will be more careful when using Jensen's method with these like low-powered analysis, and meta-analysis will definitely not save you there. That's the takeaway methods with these nice simulations to show this problem. And as we went over, we found all the standard methods. They support religiousness is associated with intelligence. And we see that the different aspects of religion have different aspects with intelligence. And so like going to church was actually slightly positive, probably because it relates to pro-social behavior, which also tends to have slightly positive relationship with intelligence, probably related to like general factor personality stuff, or even psychiatric, the p-factor. One thing we didn't cover in this video is the differential item functioning testing, and it also agreed with the results from these other methods. So what we find is that all three methods are congruent. They all point in the same direction once you have a large sample that has sufficient power to really use them. And of course, as I went into, if you want to get this data set, you just simply go here, you download every variable at once. So I made a Substack also, and of course here I'm blocking the same thing I'm blocking normally. There's nothing is Nothing is hidden. You don't have to pay. It's just it would be useful. And of course, the nice thing about subscribing to Substack is that you get an email actually when there's a new blog post, instead of having to rely on Twitter or whatever it is to be stay in touch. So, of course, like and subscribe, and I'll be back shortly with another video.